So let's get started. File, new project, Java application again. And what we're gonna do, we're gonna go week 10. Oops, that's the wrong. I don't know what I did here, but it's gonna delete it. Delete. Again, file, new project, Java application, week 10. Alright, so we're gonna have a main here finished and is ready to go. I'm gonna have multiple packages today and multiple classes, so bear with me. Before I start, just gonna comment some here for you guys. Today we're gonna talk about inheritance, which is basically what it is you can so inheritance can be defined as the process where one class acquires the property such as the method or parameters and fields. Typo in the morning, obviously. Of another. Alright, so there's one class and you can take anything from that class and use it in another class. So that's the idea, basically. There's some terminology I'm going to use here. So the class which inherits the property of other is known as subclass, or the other terminology for it is derived class or child class. Good morning. So that's the idea. So there's a bigger class and there's a smaller class, or kind of they're the same, but there's one class takes stuff from another. So that's the idea. This is the class taking stuff from another. It's called a subclass, derived class, or child class. And the other one that it actually share, and the class whose property are inherited is known as superclass, or different name for it. They call it base class or parent class. I might use superclass and subclass. Some people use it parent class and child class. So whatever you're comfortable with, that's the idea. So let's start with a basic example. Can you guys see? Or should I zoom in more? Let me zoom in a little. Alright, so here what I'm gonna do, I'm gonna go create my old rectangle class, because we're dealing with class now. We understood rectangle hopefully because we create this at least 5 times. So I'm gonna do create that, and I'm starting with the Java class rectangle. So let's have this. Just a basic one, just with the length and width, not the name or anything like that. So double length. So this is my parameters for this. Private double width. So we have those parameters. I learned that I can use my compiler to create my constructor. Now I know what it is, so I'm gonna insert code constructor. And I'm just gonna create the constructor for length and width. So right click, insert code. So this is shadowing it, and then I'm gonna create getters and setters. So insert code, getters and setters for both parameters. Done. See, easy peasy. And we have our classic get area to calculate the area. And we're just gonna return width times length. Alright, so that was our classic rectangle. Now let's create another class called a cube. So if you think of a cube, cube is let's say is a rectangle with a height. So it has length and width and height. And when I think of it, most of the things are the same except we have one extra parameters, which is the height. The only difference is the area is basically your rectangle multiplied by 6, because there's 6 sides of it. And how about the surface? Surface is a multiplication of all that, like height, width, and length. No, it's I said volume. Yeah, volume. I need more coffee. So if you think of it, it's like that. So instead of going through all those parameters again, one by one, which is redundant, we can basically make this class rectangle as a parent class, and the cube as a child class. Or if you prefer those terminologies, super class, and this one's subclass. How do I do that? So I'm gonna go here and just write that there's a keyword here. It's called an extend. So what I'm gonna do, I'm gonna extend this. So there's a cube extend rectangle. All right. So what happens here? I'm extending this class to this. So I make the rectangle the parent and the cube as a child. So that's the keyword. So I'm telling you, okay, cube is the extended of a rectangle because it's pretty much the same. I'm going to use whatever I have available in rectangle in this class. Now it gives me an error. Let me see what it is. And here we go. It says I need a constructor, a cube, double, double, and all that. So I'm going to just type this one. I have one extra parameter. So length and width, I'm getting it from the rectangle, and I just need to add the height. So I'm going to go private, double, height. So that's the only extra. I don't need to do length and width because I'm using the one in the class rectangle. So that's just for the cube's height. And now I need to create my constructor. So the constructor of the cube obviously has to have the same name as the class. That's a significant feature of and we get length, width, and height from the user when I construct the cube. Is that a typo? No. Alright. And what I'm going to do is this. I'm going to use a terminology super to link the length and width, which comes from the user here in the constructor as an input to the constructor, to my superclass which is rectangle. So these two goes here and will be set as these two parameters. So the super actually send those to the super class, which is the rectangle in this case. And for the height, since I have these parameters inside this class, I'm just simply using the same thing I did. So I'm gonna go this side. Let's try. So we have a constructor for the cube. Rectangle is still as a class itself. It's nothing to do with this one. I'm taking whatever I need from the rectangle, use it in a cube. So I make this a parent to the cube. And here with the terminology or the keyword super, I'm sending these two parameters which belong to this rectangle, and I'm setting the height which is I'm getting from each. The rest, do I need to do the getters and setters for height and for the width and length? No. You can use the getters and setters in the rectangle class. The only thing I need to do is just for the height. So I'm just writing whatever I need, which is extra or over parameters than the rectangle. So what it is here. So let's just, if you go insert code, getters and setters, it only give you the height. So I don't need to do length and width anymore because it's already done in rectangle. So it's redundant if I want to do it. So any things you have in rectangle, you have access to it here in cube. And we'll see about that. So I'm just gonna go write two things. So we're gonna calculate get surface area. We are going to return. So I can use, this is an interesting part, I'm using the method get area in rectangle, which is here, to get the result of width multiplying by width multiplying by length. And just when I do that, I multiply that by 6 because there is a 6 size to it. So you see, I'm interacting two classes to each other, and I'm using whatever I can from the parent class in this case. So volume, I'm gonna do the same thing.
You could use the same name.
What thing?
Like instead of.
We get to those topics. So next coming up, overload and override. Lost track of whatever I was doing. I was doing the volume, get volume. And I'm gonna return so what we're learning here is this. I am writing the class called cube, and whatever I have from rectangle which is similar, I'm using from there by extending this class from the rectangle, and I'm just introducing whatever is new. So the height is new, width and length is belong to the rectangle, and here, however, when I have a constructor, I need all three inputs, and I get the two belongs to the super class, and I'm sending it up there. So the terminology is super. So this is link the input parameters of the constructor. Let's say to the parameters of rectangle. Alright, so let's go try it out, see how this actually works together and actually everything's fine or not. So we're gonna go to the V10 and let's try the first things, we're gonna go rectangle. Call it rec. I'm just gonna, because I'm gonna print a couple of those, I'm just gonna create a printer. Let's call it public, just here. Don't want to keep writing these. Static void, let's call it printer. Just want to print the parameter, see what it is. It's rectangle R. So in that case, I'm just gonna print, let's call it print rectangle, or let's call it print rectangle. So we're gonna go get length, and we're gonna do that for just have these two for now. So I'm creating the rectangle called rec, and I'm just gonna give them 5 and 3. So one of the things now it's new as interesting is when I wanna print let me run that. Here we go. So one of the things we used to have, we calling the class here, right? And this is a constructor. You can always, whatever we did, these two were the same. However, this time we're gonna toss things along. So what we can do also, we can do this. We can call the rectangle and box, and we can go cube 2, 3, and 4. So the first one now, it's the parent class. So the first rectangle, then this is a name, which is in this case is box, and then we're gonna go new, and this is a cube constructor, right? With those inputs, whatever it is. Also, you can do this. We can do cube box 2, let's say, new cube, call this 12, 14, and 2. So we can create 3 types of objects. One using the parent only, is a rectangle, is nothing to do with the child. Then the second type is just using the cube, which is so this is just using the cube class. Create a cube object. Here we're using the rectangle class to generate or create rectangle object. And now this is I'm using both. So this is combination of both. So what difference does it make in order between these 3? So here, let me write 2 other class here. So we're gonna have two print class. So this one just print cube, so accept cube object. I'm just writing the things that actually relevant to the cube, not all of them. You can obviously go with the height and width, but if I want to do it, yeah, it's a T, extra T, a surface area, alright. And the volume, obviously, the volume. Alright, so we have two methods here. One accept rectangle and print length and width, and then we have the other one, they accept cube objects and print those. So let's say we have three kind of object here: brick, box, and box 2, and see how we can deal with this accordingly. So we're gonna go here, and first we're gonna print rectangle. I know that I can send my rec into this. We did this before right here. So this is redundant. And also, the good part is, since this is the parent of this guy is rectangle, I also can print this cube using the print rectangle. So that's the interesting part. This will be identified as a rectangle also. However, the access to the things are limited. So if you go, let's say, if you go box 2, dot, you see, you can get volume, height. Okay, now we have all that. Yeah, that's box. Yeah. That didn't make sense at the moment. So you can see, even box is a cube. We're using the cube. The only access you have is the thing is available in rectangle class. So we have extra things in the cube class. However, since I called this cube, create this cube using the parent rectangle here, all the things in this cube is limited to access to the rectangle class. So this is a limitation here. So the program knows it as a parent here, not the cube. So if you go send the print rectangle and send the box to it, it will work, because this method just accepts rectangle, and this box, as far as the program concerned, it comes from the same parent. So it let us go through. So if you run it, you can see, let me just have a simple separator here that we can see better. Here we go. So you can see that I can see the cube just length and width. I don't have access to, can I send that to the print cube? What do you think? So I'm talking about this guy. Can I send it to this guy here? Let's try it. Let's say I have no idea. The best way is to try. So print cube, I'm trying to send box to that, and we cannot do it though, right? So rectangle cannot become converted to cube. Even though I'm using the cube constructor, this is considered as a rectangle. Goes with the pair. So what should I do? The only thing I can do here is send the box 2 to the cube. Can I send the box 2 to the print rectangle? The answer is no, right? Hopefully. Apparently I can.
There's a cube needs a rectangle.
Yeah. There we go. Oh, that's a huge volume. So play around with those. The best way to learn is just play around, try to send that object to the other and see how that goes. I think we did enough of this. To find the relation. This is one of the benefit of Java using inheritance, and later on we're gonna learn polymorphism. Because if you, let's say you want to become a app developer, that's what you do. There's a class, you just see whatever you need and you extend whatever you want to add to the system. It's just all extended, implementing different classes and different interface. We'll get to that in a second. So let me save this. So let's go cover 2 topics. One is calling the, let's just separately create a class. It's good to keep everything separate in this part. I'm gonna talk about something called an overload. First, which is simple. So we have an overload class here. Let me zoom in. Alright, so what is the overload? Let me comment below. So this is concept that he mentioned earlier in the class, and I said I'll get to it. So overloading basically is occurs when 2 or more methods in one class have the same name but different parameters. We did this before with Constructor, if you recall. I use it overloading or overpopulating or whatever you wanna. Here it happens a lot because some classes might have the same name and they kind of link to each other, and you can just overload and use as many. You can use one name over different classes, different situation. So let's make an example of that. Simple enough. Let's say you have a class called a demo, and this one accept integer a. Let's just say this class just prints a equals to. Simple enough. Just want to get the concept here. So this is one method I have in this class. Let's have another one. So let's go overload this one. So there's a demo again. So this one get integer a and integer b as an input, and just gonna print out a and b. So we're gonna go space here. I don't like spacing in Java. Just gonna create space here for yourself. Here we go. And let's have another one. This one to get the different. So this one never return anything. This one actually, let's say, returns. So it's the same thing, but do different things with the same name, right? So this one returns, the top two didn't. So we get the double A, and we print double A. And also we return A times A, let's say. something like that. So that's enough. So you can have as many as method you want with the same name doing different things. So based on the input, let's test it. So let's have a class here. So these are just bunch of, oh, we have a, all right. So let's say this is a class overload with bunch of methods in it. That's it. And I'm gonna go write another one. So we're gonna go here and write another class. Let's call it method overloading. Excuse me. So that's my class right here. And what I'm gonna do, I'm just gonna have a main here. My shortcut for main is PSVM, and boom. So this is my main here. What's the problem? Yeah, I'm gonna fix that later. I think I have extra parentheses here. Yeah, this is not. All right. I think that goes. What is the problem? Yeah, we need the parentheses. We have to close this one here. So this is one class. You can have two classes or more in one class file, let's say. And here is another class. So I have a main here. I'm just gonna create a bunch of objects. So we're gonna use the overload class on the top and create the object out of it. Do I have overload? I don't have overload. No overload. Forgot the name of the object. Alright, so let's have a variable double result. It's a dummy object anyway. You just want to use the methods. So we're gonna go object dot, and you see you have all those available for you. So you can use, let's say, just type demo 10, and then we're gonna have object dot demo 10 and 20, and we're gonna have a result equals to, that's the third one I'm using, which is get the double. So we're gonna go double, what am I doing? Double, let's say 5.5, I don't know. Anything you want to put in. And then we're gonna print, what's going on here? Oh yeah, forgot the object. So you're gonna go object dot double. No. Object demo. Send the double into it. Need more coffee. So we're sending a double here. So I'm sending this. The first one I sent 10 to this. Let me just minimize that. 10 and 20 to that one, and 5.5 to this one, and I'll store the result here. So whatever it is, so 5.5 multiplied by 2. No, sorry, to the power of 2, because we're multiplying it to each other. We are gonna print the result is alright. So this is called an overpopulation. I have a class. It's full of methods with the same name doing different things. And I have another class with the main, which I'm just creating the object, and so I think like if you run a separate class was F5 or F6. Let's just try it. There was a run. There is a run. There we go. Alt and F6, right? So we can do that. Oh. So for running the separate file with the main, which is not the same name as your project, which is overload, we're using Shift and F6. And you see every single one of them works separately, even though we had the same name for each method. So that's called overloading, and you will see that in inheritance and using different classes at the same time. So you have the same name, just each class doing different things. We did that. There is another one called that overriding, and I'm going to cover that. We can take a break. Alright, so now we're going to create a bunch of classes. Simple classes though. We're going to go base class. So now, so what we learned was, so here in the base class, I'm just gonna go and create the method, call that method to override. We are going to talk about, so we talk about overload, there's something called an override. So there's a difference between those. And override is a feature that allows a subclass or child class, whatever makes you happy, to provide a specific implementation of a method that is already provided by its superclass. Let me just specific, there's extra F here, and a method, there we go. So let's say I have this method to override, and just want to make sure. And this method, basically what it does is just print here we go. So I have a base class. In this class I have one method, and that method just prints I'm in the base class. So whenever we run that, it shows. Let's have another class, create another one. And this one we're gonna call it Derived Class or child class or whatever you want to call it. So I'm creating another one, and in that one we're just gonna do the same thing. So this is the same name, but it's in different class. And what I'm gonna do, I'm just gonna print so this is a base class, this is a derived class. How do I know this is a derived class? Because I'm going to extend this from the base class, right? These two are mutually exclusive right now. We're gonna make one of them parent. So the parent is the base class, so I'm gonna extend this to the base class and see what happens to the method I have under here. I mean, like the method to override. You see, it gives me this guy here, and it says, okay, add the override annotation. So that's what it is. Here I am overriding. Let's put it this way. You have a method in your superclass or your mother class, and you want to use that, but you want to modify it. You want to add the context, right? You want to override it. Because before, what we can use whatever we had in rectangle, but we just used it. Now we want to kind of override it, just write something else to it. And that's the idea. It's different than the overloading. Overloading is like a couple of methods in the same class has the same name. This has different relations. So it's one in the parent class, the other one is in the child class. So let's see how these two works together. Let's go to my main and create a bunch of objects, see how I actually work together. How about that? So this is my main. I did for the rectangles. Now I'm gonna move it forward. Just gonna have a separator. So this is a separator. And what I'm gonna do, I'm just gonna create the base class first. So this is object one. I think yeah. Here we go. What else is missing? Oh, forgot to. There we go. So that's your object one. What I'm gonna do, I'm just gonna call object one dot method to override. And if I do that, I'm just gonna see the method that I have in the base class. So I'm creating an object from the base class. I run that method to override, and I see, and that method will be run from that class. That's no brainer. So let's do this. Let's do base class object 2 now. So I'm using the parent class, and I'm gonna go new derived class. So now I'm gonna go object 2 method to override. So who can guess what do I see here? Anyone can guess? So this is the idea. You're right. They're both gonna show up. Why? Because this is hybrid. So this is interesting. So now if you do derived object 3, so now if I do that, obviously this is an easy one. Oh, I have a typo there, right? So let me go fix that.
No, you are wrong.
I'm wrong on what?
Yeah.
Alright, yeah, like you need a separator. Yeah, I was going to do that. I realized here. Yeah, so I'm gonna separate them. They suggest it's easier to see. Here we go. So here in this output, you're gonna have both, which is interesting. Both of the overrides statements together. And here you're just gonna see the override method in base class, and Here, obviously, you're gonna see the method override in derived class. So that's the idea here. Let's run it, and in that case, it's much cleaner, and you can see. So this is overriding the first one, base. No, no, it's not both though. Yeah, like that's what. Yeah. Okay, yeah. Now that makes sense. It's not both. Okay, so I made a mistake because of the separation. It's just you see the derived one. So in that case, you're just gonna see the derived class. The funny thing, he said both, and I saw both, and my brain clicked. Anyways, all right, so let's do that. Okay, so you got the idea. The best way to just play around with this, see what's going on. I am going to maybe I should want to break now, or you want me to have one more tiny little class? Let me finish that, then we can take a break. Let's. This is interesting. I'm gonna talk about abstracts method. So we talked about override. What was the rest? Forgot. Overload. Yeah, overload, override, and now we're gonna talk about abstract. Somebody taught me like overpopulated, and I just stick to my mind. It just because you populate a lot, and it's just try to use the right terminology here. So we're gonna talk about abstract method. So we're gonna create a class called an animal demo. All right. All right. So we're gonna create some sort of parents for. All right. So before I continue here, I'm just gonna have a main for my demo. I'm just gonna have a PVM. What was that? PS. Yeah. Public static void main. No suggestion. Should give me that. Here we go. So I'm just gonna create a main for this class. So this is my demo with the main. Now on the top, I'm not gonna go multiple classes inside the package. I'm just gonna do everything in one file here that you guys can see. We're gonna have a parent class. So we're gonna define a parent class called animal. So this is something that all the animal have, right? It's a parent class. So parent class is something on the top that you can branch out from it. Let's say you can have mammals or birds, and then you can have different birds, or let's say shapes, and then you can have different shapes. So we're gonna find something common. So animals, this is a good one. So we're gonna go public class animal. And we're just gonna have a simple private string. We know each animal has a name, so that is common. And we're just gonna have a constructor here, and we're gonna call it animal. And that what we accept a string and call it name, and we simply set this name to the name. So we're gonna do that. What's the matter here? All right, and let me just fix this. No, later. And I'm gonna fix that one in a second. Just let me bear with me here. And what it's gonna do, this animal will. Am I in the parentheses? No, I'm outside of the class. Yeah. All right. So the animals also, what they do, they speak, or they're making some sort of noise. Let's say. So we're gonna have another class here. I'm gonna go public string speak, and in this one, what we're gonna do, we're just gonna return the name of the animal. So we're gonna return the name. So it's like, let's say cow or horse or whatever it is, and then we're gonna say, okay, says, and we're gonna create a method called as sound. I haven't write the sound yet, obviously. We're gonna do that. And this is the interesting part. So I have this parent class that I have a variable called a name. Whatever the user give me, that would be the name. But I don't have the sound. Each animal has a different sound. They have this method that says sound, which is creating the sound, but I don't have any. So I'm going to introduce something called an abstract method. What is it? So let's do that. So I'm creating a method. So I have public, this is the output, and I'm adding abstract here. What abstract means is this, and I have the semicolon at the end of it. This, just comment that, this is important. So abstract method is a method that is declared but has no or contain no implementation. In other words, you just write the method header. You don't write the body of it or anything. We know animals has sounds, but each sounds can be different. I don't have that sound now, depends on the animal, but I know they have sounds, right? So let's say sheep say bad, horse say, I don't know what they say. So they have different noises and sounds, but I don't have it. I know just they have it. So this is an abstract method, which is a method that contains nothing, just the header. Then we can fill it up later. So that's the thing. So this is a keyword. When you do that, it lets you write. One of the things you guys are going to pay attention to that's important is if you have an abstract method in a class, that class has to be abstract too. So in that case, you have to have an abstract class instead of, why I have this error? Yeah, here we go. So this is now the abstract class. Important, really important, again, one of the common mistakes. So if you have an abstract method, this is the method with the header, there's no implementation yet. You're gonna fill it up later or just override it or whatever you do. Your class also has to be abstract. So I'm gonna make that comment again. An abstract method has to be defined in an abstract class. Create. Alright, so what else is new? So let's kind of use this parent class. Let's have multiple subclass, but tiny ones. How about that? Let's start with, we're gonna override the sound later, obviously, right? Because there's nothing in it. So we have to override it with new content. So let's start with the basic animal. So I'm gonna go out here and I'm gonna define another class, call that cow. And we're gonna extend that from animal. So I'm making the class cow child of the animal or subclass of the animal. It makes sense. And we simply, now we're just gonna go override the, not override, we actually create the constructor. So we're gonna go string name, and we're gonna link that to the top part because it's the same. So I'm gonna go super name, whatever user give me the name, I'm just gonna send it to this guy here. So I don't need, the parameters is up here obviously, so I don't need to define the parameters for a constructor. Just gonna define a constructor for this class, because guess what, the class name and the constructor name has to be the same. So when I have a class cow, I need to have a constructor cow. So we get the name, then I send it using this keyword super up here, because the actual parameters defined in the parent class. Here we go. And what else I have to do is now I'm gonna make the sound of the cow, right? So I'm gonna go public. So now I'm gonna use my abstract class I have and just define sound, which is an empty one, and this one is just return, I don't know, let's say moo, right? Cow say moo. If you have a better sound for this, let me know. I think I have extra parentheses somehow. Right. This is wrong, so this is here, 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 here. So you see, it gives me this. So you kind of tag it, and it tells you, hey, you override it, right? And it says you implement the method from the read10 animal. So it gives you what's going on here, right? So it tells you, okay, you're implementing this method, and you're overriding it with a return, which is this one. We tell them we have a return, but we never said what. All right, so that's one. Let's have another one. We can have multiple of those. So we're gonna have a class. Let's call this horse. If you have a favorite animal, it's a time to share that here that I can use. So I'm gonna just use. Here we go. You see, if you right click, it says you can say implement all the abstract method. See, right there, you can insert it and simply go return, and so horse make noise of that, something like that. I don't know, can't really write the sound of horse. And obviously I need something else, right? What is it? So we need the constructor horse. It tells you. So if you communicate with the your compiler, it tells you what you need. Boom. So most of them is easier. I'm typing because I wanted to teach you, but when you have that, just right click, insert code. Just boom boom, just keep continue. The other one, let's have another one easily. Sheep. And again, click here, implement all that, and click here again, make so the constructor for the sheep, and the sound. This is the exception they throw it. We're gonna cover those later, but here we go. We're just gonna return the sound. So sheep says bah. They do, right? Alright, that's enough. So let's now go to my main class here. I mean, like the class with the main, and try to create those. So we have animal H, which is a new horsey. Call that CJ. And then we're gonna call. The good part is we don't have any. The speak is in your parent class. So every time you don't need to define the speak, you just define the sound. So I can just call h.speak. So for the cow, so call the cow AZ. I don't know. So we're gonna just go see speak. Speak to me. You can directly obviously call the sound, but let's do that. And we can also do that. Let's for the sheep, don't do it directly. So we're gonna go new sheep, and we're gonna call it little lamb. I'm not assigning any object here. We're just gonna create it because we just, and then we're gonna do dot speed. Can do that. Yep. So what happens? I'm using the parent class here. Oh, we're gonna go Shift and F6, and here we go. So CJ says, all right. So we need a space again. I'm forgetting space here, left and right. Let's return those with the space. How about that? Got used to the Python programming. There is no space there. Life is easy. Here we go. So CJ as a horse. So CJ is a horse. Yeah. Makes sense with the noise, right? CJ says that or knee, whatever you are using it, and Basie says moo, and little lamb says bah. Right, so we're using the parent here, so animal, and here also, I don't even define anything, just directly calling the constructor here, and we can have it. So this is called an abstract method. So there's again the method abstract method, two things. If you didn't get anything, abstract method is a method. It's your headers. It doesn't have, there's no implementation. There is no body or anything. It just tells the program what it is for later use that you can override. Key point, abstract method has to be an abstract class, right? These two you have to take it from there. All right, let's take a break and come back with more new stuff. Okay, so we're gonna all right, so let's continue. I'm just gonna open a new package. Try to keep them separate. It's too many classes, right? I'm just gonna go with a new package now, and let's call this, I don't know. Let's call it like a poly, short for polymorphism. And, finish that, and I'm just gonna create a Java class. Let's start with multi interfaces. So the polymorphism, there we go. Let's just write the definition for it to begin with. Boring stuff. So polymorphism is the ability of an object to take many forms. So the common example of it is when a parent class reference is used to refer to a child class. Right, so the common is basically instead of going that way, go backwards. So that's one of the common things there is. So in Java, any Java object that can pass more than one parameters considered polymorphic, something like that. All right, so those are definition. You can search it up. Just put it there. Parameters. What am I missing here? There we go. Okay, so let's get the idea what's going on. We start simple and try to implement more and more as we go. Alright, so that is multi-interface. So let's say I can have it. So instead of client class, we can have interfaces. What it is, let's say we have an interface. So interfaces can kind of interact with all the classes. So let's say we have an interface, we call it I1. And in that, we're just gonna have an abstract. It's really common to have an interface separate in a separate class, but for now we're just gonna do that like this. And in that interface class, we're just gonna have a integer I. Again, we have an abstract class, means I don't need to have any implementation at the moment. Just gonna leave it like that. And let's have another one. So there's another interface. Oh, I think I'm out of the. No, I'm still in the. Oh no, I'm not writing those here. Sorry, those are classes, right? I'm gonna write those outside of this. So we have the interface class I1. It has an abstract method test here, and I have I2 interface. And that's abstract method. So I don't know what it is. I don't know the implementation now. Just gonna. This one has a string. Alright, so these two are two interface classes, and what I'm gonna do, I can implement both of them into my multi-interface class. So we learned the extend, which is link the class to the parent class. Now we're gonna use the keyword called an implement. Guess what? You can use both of them. Like you can extend a class from the parent and also implement the other class to it. So you can go the combination of both. But we're not there yet. So we're gonna go I1 and I2. So what I do, alright, so what I do, I implement I1 and I2, and I'm just gonna override these two test methods because they're abstract methods, so they're empty methods. I'm gonna tell them what to do. And in this one, I'm just gonna so here I'm in multi. So here I'm calling this method here from this class. You'll learn this more. I just want to tell you what it is format wise, and we're gonna make good example out of this. So what I'm happening, these two can be anywhere else in different classes, different location, but I just put it next to each other. We implement these two. These are not parents child, they're just one class implemented into another. Could be cow implemented to sheep or whatever class it is, so they can actually go in. And in this case, when I'm writing this with the integer I, which is comes from the top, I'm just overriding this. And for the string, I'm just overriding the other one. Just let's have a main and run it and see how that works. So PSVM, and so we're gonna define the object multi-interface, and let's call it T, and I'm gonna go new. So if I do T test and I send let's say an integer, we'll print this message. And if you do T test, I don't know, Hassam, it will print that one. So let's go Shift and F6. And here we go. So what it is, I'm implementing that there's two classes, but they're not the actual class, they're interface classes. It means you can interact with anywhere, any location you want. And you can see there is an I next to him, and here it's your tracker. You're gonna pay attention to the tracker. These things can actually get complicated as we go. You can take a look at the left side as well. So the multi-interface implement I1 and I2 here, and that's what's going on. This has really become handy when we navigate through these different classes. So this is an example of it. Let's have a better all right, so let's have a better example. So I'm going to have a Java class called car. Simple. Oh, sorry, I took it in the week 10. I'm just going to move it to the poly. I will try to keep separate everything from the break. So I'm going to refactor that. So I have the car here. It's in the package poly. I'm just going to zoom in right there. And what I'm gonna do, all right, no, we're gonna introduce you, let's delete that, let's delete it. Now let's do something better. We're gonna right click here, go new, and going to, no, okay, let's just, we're gonna change it. I think it had the interface before. Here we go. So Java interface. So this is a class designed to interact with another classes. So I'm gonna select this now, Java interface. Here we go. So we're gonna call this car. And here we go. So by default, as you can see, you go public interface car. So let's say in that interface class, I leave, we can even have parameters. Let's say there's a speed of the car, which is 90. I can have that. Since it's public, everyone can use it. And I'm gonna have a public void distance. So this is looks like an abstract, right? But I don't define the abstract here, because the interface classes are designed to override and just use anywhere, so you don't need to define. Let's have another one. Let's go public interface bus. So we have cars and bus in there. You can throw bicycles even, you like, whatever you need. So in this one you have distance 100. That. Yeah, that's okay. Okay, so this is an example of the interface. There is a class interface, and it has. No, wait. No, I'm gonna do this two class. This is wrong. So this has to be here. So this is a car class, and I add another one. No, wait. What am I missing? There's a parenthesis somewhere. No. Okay. Okay, so I separate them. They're not one. There's two interfaces in one interface class. So there's a car, has a parameter speed, and the abstract method distance. And this bus interface class has a parameters distance, which is 100, and the method speed, which is there has no implementation. Why? Because they interact there later. We're gonna override those. So now let's go play around with these two. So we have the car, it has a key there. So let's go play and let's have a Java class, actual class, call it vehicle. And what I'm gonna do, that's the thing. I'm gonna implement car and bus to the vehicle. So there is a two interface, right? So in the car we have this guy and that guy. So what I'm gonna do, I'm just gonna implement these two, so you can have multiple implementation, obviously. Bus and car, both of them, to the vehicle class, so have access to whatever is in there. So in that case, we can simply go and override our methods. So there was two methods. I'll right click and I'm gonna override these two. So one of them was in, this is in car interface class, and the other one is in the bus interface class, right? So this is interesting. I'm gonna do a little bit of math here. So we're gonna have integer called a distance, which is I'm gonna use speed. So where is the speed? Speed is here in the car interface, so I can access that easily because I'm overriding this method. I implemented the car, so you have access to this. Multiply by 100. Let's say that's a math for that. and we're just gonna print out and this one, let's have a speed. Oh, not that. Distance, the parameters divided by 100. So what am I doing? I'm using the speed and so I'm using the distance and speed. Each of them are in two different interface class, and I'm overriding it with the parameters to generate something new. Where is it? Sorry, here we go. Okay. So this is my class. So where should I? Do I have a main here? Yeah, I have a main. Let's just generate things here now. I guess that's the best way. Or maybe I should have a demo separately that doesn't confuse you. Or maybe I should do it here. Let's just keep it separate. So I'm gonna have a demo to just print those objects. So demo vehicle or demo it is in the same package, so I don't need to do anything else. So now I'm trying to create some object here. PSVM. Always bad with memorization. Right, so the vehicle, now I want to generate object out of this. I am going to do vehicle V, and I'm gonna go new vehicle. Oh no, that's a small v, right? And I don't need anything else because every parameter is given. So we can go v dot speed, and that should give me the speed of the vehicle, whatever it is, and v dot distance. So there is no parent class, there is no subclass, they're just interacting, interfacing, implementing one class to another. Something like that. Now, oh, yeah, Shift and F6. Here we go. So the speed is 1. Okay, let me just go check it. Let's go to my interface class. Not here, the vehicle class. The gap would be nice. Yeah. So we can even go change that to. Oh, wait up. The speed is 90, right? Distance would be 90 divided by. Yeah. Okay, yeah, that's fine. So the speed is 1? Really? Yeah, okay. Distance 100 divided by. Let's just make it 10. Yeah. Try to do some math on it.
Calculating speed in distance and distance in speed.
Yeah. Try to. Distance is a speed time. Like it's 70. So let's say 70 kilometers per hour. It's 90 kilometers per hour. Let's say so. If each kilometers is.
Okay, but this is the distance method. You should divide by 100. You are in the distance method.
Doesn't mean anything. Just try to put some math here. Let's actually find something for it. Yeah, those are generic formula. You find the formula, put it there. I just want to show you how to interact with these. The math is not the case here, right? Put any math you want. Go search it up how to convert one to another. Sorry, I lost track of. Yeah. Okay, so let's do something a little bit better, like something more comprehensive. Then we're gonna wrap up today's lesson, and we continue next week with more example of this. Gonna create another package. It's a new package. Here we go. And this one we're just gonna go. Let's say retail. All right. So we have a retail here. Let's just. All right. First thing I'm gonna create. I'm gonna go create the interface. This class, interface class, gonna interfere or kind of integrated into a couple of other classes, which is we're gonna go. So let's go retail item. Here we go. So I'm having a and in this interface class, I just have a all right. So this is what it is. Think it as this one. Look, the interface class. It's a collection of all the classes with no implementation. So you have a headers of the classes that you might use in any other classes. It's not a simple topic to understand in the first shot, but we'll do our best every week to try different things. Okay, so we have this guy which has no implementation yet, so we have to override it. So this is just your class header, and now we're just gonna go generate a couple of classes, basic classes. And first, we're gonna start with DVD movies, if they're still out there. And this is a fully class. And what I'm gonna do, I'm gonna implement not there. All right. So what happens right away? It tells me there's a DVD movie is not abstract and does not override abstract method get retail. It tells me because you implement that one, you have to override it, right? So that one of the things is that you're implementing the abstract method, you're gonna override it. I'm gonna just use this, make my life easier. But before I do that, I'm just gonna create my whole class, then override my abstract method. All right, because I don't want to complicate things. So the first thing I'm going to do in the class, oh, okay, it's already there. I'll delete it. Okay, so what we're going to do, we're going to define a bunch of parameters in this class. It's an old-fashioned class after all. So it's a string title. So this would be the title of your DVD. And there would be a private integer running time of that particular movie. Is that 2 hours, 3 hours? If it's an Indian movie, obviously it's 8 hours. But, this ones usually go up to 3. I see like long movies back in the day. Alright, so the retail price, so how much does it cost? So those are the parameters. And I simply gonna right click here, insert code, create my constructor for all three, right? Simple enough. So when we create the object, I need these three to be inputted and set it to those parameters. I need my getters and setters, so I'm gonna go getters and setters, easy peasy. Boom. So each parameters has an input and output as we talk because they're private. All right, so now what I'm gonna do is still I have this problem, right? So we have to here we go. So this is the method which is we over. Oh, okay. Sorry. So this is the method here. I'm just gonna add the override to now. This is what we override. So the get retail price. I have the retail price here, right? But the get retail price is the override of this method. If you click here, it says override, and you can actually go there. If you go here, you have a retail price here. This one is not the regular get retail price. This one is overridden. Here we go. So you can click here and it takes you to the location. The question is why we need to do that. And when I've done different classes and I try to print things, I will show you. So the class is the same thing. I'm implementing this, and when it gets to the retail price, I'm just overriding now. Let's do another one. So this one is, let's say, compact disc. And don't ask me what's the difference between compact disc and DVD movies. You're lucky I'm not doing VHS though. So compact disc. So again, what we're gonna do, I'm just gonna implement my abstract class, implement readable item. So that's the giver. So we're gonna have this one. The compact disc basically is not a movie, could be music, or since you ask. Private final string title. So you can have a title. It has an artist. Final string artist. And again, so this is another item. It's the title and artist is different than the movies, or basically DVD movies. The only common thing is the retail price, right? All right, I love the way everything is red. What's going on? All right, we do that. Look, so we need the constructor. Right click, insert constructor. So we're gonna create a constructor for all of them. So that is good. And now we're gonna set the getters and setters. Maybe we're just gonna do get. I don't want to complicate things. We don't need setters, just get information, right? Actually, what I'm gonna do, I'm gonna change that on DVD movie Java file 2. We just where's the insert? Here we go. We just, instead of getters and setters, we just gonna do getters. Here we go. And that one obviously is the override because it's I'm gonna add the override. So this is the implementation of here we go. So it returns retail price. But this is an override. So it actually not belong here, it belongs to this guy here. For this guy also, for a second, for the compact disc DVD, I'm just gonna do the gets. I don't need the sets. Sorry, where's the No, not the compact disc, the DVD one. I did too many. It's confusing because that's not the concept here. I'm just gonna redo it really fast. Just insert code and just the getters. That would be enough. That's what we care right now. So we set it once, and that's it. We just get the information, obviously. And do I need another one? And that's enough. Let me see. That should be enough. So now let's go and see how these three actually work together. You have two items. They have different parameters. They have one parameters in common, which is the price. Which makes sense, right? But every item in the shop is different. So the only thing they have in common is the price. And I keep that price method in the separate class, which is your real retail item for that. So this is the common. The beauty of this is this. So I'm just gonna generate another Java class, and we're gonna call that let's call it polymorphic interface demo. Here we go. See, we have too many classes after all. And this is the last class. So we're gonna create the main. It was PSV, public static void main. So that's that main. So I'm gonna create a bunch of objects here from those and see how those work together, right? So obviously we need two objects, one compact disk, and let's call it CD, new compact disk. So we're gonna name it greatest hits. That's the name of it. The artist would be my favorite one-liner Richie. If you don't know who it is, search it up. And the price is $18.95 plus tax, shipping and handling, and all that crap. All right. Oh, the typo. As usual, the team is missing. Here we go. So this is one object. Obviously, you can do multiple. You just want to find out so now we're gonna have a new movie DVD. Where is it? DVD movie. That's why I didn't do the English major or anything like that. I just can't write. So the name of those would be Wheel of Fairy, let's say. I think Fairy has one R, and the time of it, let's say 137 minutes, 12.95. That's the retail price. So you see, these two are totally different items. The only thing they're common is the retail price, and I get that one and separate them and keep that in. So interacting with this two items will happen when you want to get the retail price through your interface class. I will see how in a second. So where is that here? Polymorphism. So you want to see those prices, right? If you recall before, if I go to rectangle, if you recall that, in order to print those, I generate two different classes because there was a parent class, there was a child class. They cannot interact with each other. You cannot print cube in rectangle class and vice versa, right? So we have this method, accept rectangle, this is cube. So back to this one, this is a good part. I'm just gonna generate a private, because the price is private though, right? You don't want anyone to see it that easy, but it's static void, so it belongs to this class here, and we're gonna go show price. Oh, yeah. So what I'm doing is this. So this method only accepts the input that is objected from the retail item interface class. Means what? Any classes that override that method can use this method as well. So what I mean by that is this. So if you wanna, let's say you go, okay, I wanna see, oh, not here, let's just go back. Let's say item number 1. So item number 1, which is the CD, we want to get the title, we use the get it, right? So you want to show the price, you can just show price and send the CD to it. Since CD has the basically overwritten or override method from the interface, it can actually go through this. So here what I'm gonna do, let's go, let's just use a printf. It's easier that way. So we're gonna go, okay, price So the retail price is common between these two objects. However, we're not sending those separately. So I don't have like multiple of this class to print the prices because they have different object type. So we can really print the CD price here, and also we can do the same thing with item 2. Let's say, let's get the movie title, or 20. So this is movie dot get title. Here we go. And for the price, I can use the same thing. So I can go show price and movie. All right, because that particular retail price are implemented from another class, and we can send any object into that and get the price instead of writing 10 different. Let's say you have retails of 100 items and you want to show the price, you're going to write 100 classes for that. So now we're doing 1. I mean, I think that's beneficial. Oh, forgot that. You're going to go shift and F6, a little bit of space maybe. Here we go. So you can see the price actually run through both. Shift and F6. Here we go. See, every time I get the price through this guy here, because that's a interface method which is implemented through the separate part or separate class. The best way of understanding is create your own classes that interact with each other. So we're gonna have an assignment related to these topics. We're gonna stop here.